Hello learners, welcome to my YouTube channel again. Previously, we were introducing chemistry of acids, bases and salts. In lesson 1, the last section that we have done was comparing the strength of acids and bases, where we were using the degree of dissociation, where we were saying strong acids are acids that when dissolved in water fully dissociates, producing many hydrogen ions as the only positively charged ions. We are dealing with weak acid, strong base, weak base. Today, we are going to compare again the strength of acids and bases using the pH scale. What is pH scale? pH scale is the degree of acidity and alkalinity of a solution. So, if we start with acidity, acidity depends on the amount or the concentration of hydrogen ions in the solution. Remember, we are dealing with acid, so acid, we are dealing with hydrogen ions. Hence, strong acids have a higher concentration of hydrogen ions, while weak acids have a low concentration of hydrogen ions in solution. The pH scale, we have learned it in Form 1, acid, bases, and indicators. We said the pH scale ranges from 0 all the way to 14, where we were having the center 7. Then below 7, we were having 6, 5, 4, 3, 2, 1. So these were acids, because we are told acid will have a pH below 7. So acids have pH range from 0 to below 7. What about alkalinity? Alkalinity. It depends on the concentration of the hydroxyl ions in solutions. Hence, strong bases have a higher concentration of hydrogen ions, while weak bases has low concentration of hydroxyl ions in solution. So if we use the pH scale, bases, they are going to have a pH more than 7 up to 14. That's 8, 9, 10, 11, 12, 13, and also 14. That will be the pH range of bases. Number 2, let's talk about a second again, electrical conductivity. The electrical conductivity of electrolyte depends on the amount of ions in solution. So we say the higher the number of ions in solution, the higher the electrical conductivity. So we can compare this using the amount of deflection on the ammeter. So if you are dealing with strong acids like hydrochloric acid and bases maybe like sodium hydroxide, they cause a greater deflection on the ammeter. While if you are dealing with weak acid or weak bases, for example, ethanoic acid, or you are dealing with oxalic acid as your weak acid, and you are dealing with calcium hydroxide as your weak base, they are going to have a lesser deflection on the ammeter. Number 2, we can again see the electrical conductivity on the amount of brightness that a light can give out. So I told strong acids and bases, they produce a higher bulb, a brighter bulb, while the weak acids and bases, they produce a dim bulb. That's when you consider electrical conductivity of ions on the amount of brightness that they produce. Next, let's go to the third. We can compare again the strength of acids based on their chemical reactions. This one is mainly for acids. So the rate of reactions depends on the amount of hydrogen ions in solution. So these differences in the rate of the chemical reactions depends the amount of the gas produced, that's 1, and the rate of the effervescence. That means if you are having a metal, and that metal you are reacting with acid, and that acid is a strong acid. Remember, when a metal is reacted with an acid, what we are going to get is salt and hydrogen gas. So hydrogen gas, it produces, or it's a gas, hence we are going to observe effervescence. So what about the rate of that effervescence? We consider the acid, is it strong or weak? If it is strong, that means the rate of effervescence will be rapid. So we are going to observe rapid effervescence. So student, if you are dealing with, again, maybe a metal with a weak acid, that means still we are producing hydrogen gas, so we are observing effervescence, but the rate of effervescence will be low. So in case you are dealing with a metal carbonate, when you react with strong acid, still we are forming carbon dioxide. That means we are still seeing that effervescence. So the rate of that effervescence when a metal carbonate reacts with strong acid will be again rapid effervescence. That means that effervescence will be rapid. That is the gas produced and the rate of effervescence. After that, let's just try to have examples. We are told in an experiment, a student tested the pH value of various solutions and recorded her result as shown in the table below. So we are having solution A, B, C, D, E with pH value 7, 8, 13, 5, 1. So we are told classify each solution based on its strength. So when you are told strength, we are having only 4 strengths. One is strong acid. 2, we are having weak acid. So 3, we are having strong base. Then 4, we are having weak base. So the pH value for strong acid, they range from 0 to 3. The one for weak acid will range from 4 to 6, that means below 7. Then strong bases will be from 12 all the way to 14. Then the weak base range from 8 to 11 pH value. So using now the table here, let's just classify A. A is having a pH of 7. So, and in the pH scale, we are having something called neutral. So neutral value or neutral solutions have a pH value of 7. So A will be neutral because it has a pH value of 7. So B, it's having 8. So in our thing, 8 is a weak base. So that means B is a weak base. So C is having 13. That means from our graph here, 13 is here. That means strong base. That C is a strong base. What about D? We are having a pH value of 5. So where is 5 here? 5 is weak acid. So it's weak acid. Let's check E. E is 1. So 1 is in between 0 to 3. That means it is strong acid. So when you are told classify solutions based on their strength, the teacher is expected to use, say, strong acid, weak acid, strong base, weak base, or maybe if it's neutral, you state that it's neutral. Next, let's see B, comparing the electrical conductivity of solution B and C. First of all, let us see what are B and C. B and C. B is having a pH of 8, then C a pH of 13. So what are they, first of all? What nature does B and C is? They are now bases, because we are told bases range from a pH value of 8 to 14. So if it's like that, and they're asking us to compare the electrical conductivity, we said electrical conductivity now depends on the amount of ion present in that solution. So what have we said the next? We said the stronger the base or the stronger the acid. Here we are using base. The stronger the base, the higher the ions that are present in that solution. Hence, the higher the electrical conductivity. So here, C is strong base. So that means it's having a higher concentration of ions. Then B, which is that side of a weak base. So you're saying answer, C is a better conductor than B. Reason? Because C is a strong base. Therefore, hence, it ionizes or dissociates fully in water to release many hydroxyl ions than B, which results into a better electrical conductivity. Okay, C, we are told compare the volume of the gas produced when maple chips or calcium carbonates are put in separate test tube of solution D and solution E. So let's go to solution C and solution D. What are solution C? Solution C, we are having, solution D. Solution D is 5. That means it's an acid, so it's weak acid. So solution E is acid because we are having 1, and 1 is strong acid. So what have we said about evolution of gas? We said the stronger the acid, that means the stronger or the higher the rate of effervescence. So here, 1, that's E, is a strong acid. So the test tube that was containing in marble chips with the solution E will have now a rapid effervescence. Okay, let's check. We are saying E produces more volume of carbon dioxide than D. Reason? This because E is a strong acid, therefore a fully dissociate to give many hydrogen ions which will react with the maple chips or the calcium carbonate, then D. So if you're told which substance is likely to be pure water, that means which one is a neutral solution. That's what they're asking us. So it will be solution A. So next, let's go to acid-base reaction. So acids react with bases to form salt and water. For example, if you're having sodium hydroxide, it will react with hydrochloric acid to form sodium chloride and also water. This is a neutralization reaction. So what will happen here? That means sodium hydroxide has hydroxyl ions which are in solution form, which will react with hydrogen ions from the acid to give you water. So this is the ionic equation that will take place in this equation. So we are told during reactions, the hydrogen ion from the acid reacts with the hydroxyl ion from the base to form water. Okay, after that, students, we go to the extended question. We have one question, try to attempt. Inshallah, next time, let's meet on the next class as we look on the effect of solvent on acid-base character. Thank you. Goodbye.